This is a reminder of the activity we did in class where we created a histogram from a set of data. This is the same set of data that we used then. This is the answers to the question that we asked in the class survey about how many U.S. states that you have visited. The data here is presented as a stem and leaf plot, and if you remember, that means that the digit to the left of the vertical bar there is the first digit of one of the data answers, and the numbers on the right side of the bar tells you all the different second digits of those answers. So in the first line, when it says a 0 with the bar and then 133, that means there's 3 data points, one with the first digit of 0 and second digit of 1, the next one with the first digit of 0 and the second digit of 3, and the third one also with the first digit of 0, second digit of 3. So that first line is reflecting the 3 data points, 1, 3, 3. The second line has lots and lots of data in it, but if I pick one of the ones further down, so for example, this line, the third one from the bottom, the first digit is 1, and the second digit can be 5, 5, 5, 7, or 8. So that's listing really 5 different data points. They would be 1, 5, 1, 5, 1, 5, 1, 7, and 1, 8. Finally, the last line are the data points whose first digit is 2 and the second digit is 6, and the first digit is 2 and the second digit is 8. And so those are the 2 values that we saw of some people in class who had been to 26 or 28 U.S. states. So that's what all of our data looks like. When we created a histogram, the idea was to start off with a defined width of a bin. And in this case, I decided that I'd like the bins to be width 4. And the reason I use width 4 is because that gives me 1, 2, 3, 4, 5, 6, 7, 8 different bins. And that allows us to see the data spread out. If we had too many bins, there would be lots of them that were empty. And if we have too few bins, then there would just be one giant bar or 2 giant bars. So we want to try to strike a balance. So I'm going to define bins of width 4. So what I'm counting is all of the data values, the number of data values that are in this range. So you see I have listed here 0 to 3.99. In other words, at least 0, but not as much as 4. And there are 3 data values like that, specifically these guys from our first line. Those are the only data values that are at least 0, but not as big as 4. The second bar is going to be pretty big because the second bin are all the data values that are at least 4, but not as much as 8. And so I can count those as well. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of the ones I just put green dots under, those all are at least 4, but not as much as 8. So there are 10 of those. So I'd say my count is 10. The number that are at least 8, but not as many as 12, 1, 2, 3, 4, 5, 6, 7. So there are 7 in the third bin. In the fourth bin, I want numbers that are as at least 12, but not as much as 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 values that are at least 12, but not as much as 16. The next bin would be numbers between 16 and 20. There are just 2. The next bin would be numbers that are at least 20, but not as many as 24, and you can see there are actually none of those, so this will be an empty bin. The next bin will be numbers that are between 24 and 28. There's 1 of those, and the number that are at least 28, but not 32, there's 1 of those. So we can double check to make sure our bins actually add up to the total number of data values. The sum of all of those numbers is 33. So we know we have everybody accounted for. And so when we're ready to make a histogram, to actually create our histogram, let's see, I've got a scaling problem here. Well, I'll just remember what I said. On the graph, the main thing is that the x-axis is going to be, well, first of all, we want to label the x-axis. The x-axis here, the horizontal axis, is reflecting the number of states. And I'm going to draw bends that are where the width sits right on top of the range of values that the bend was created. So the number 0 to 4 was my first bend, so my first vertical line there is going to be at 4, then at 8, at 12. So these lines I'm drawing correspond to the ends of the bends that I've defined. Then all I need to do is draw a bar graph so that the height of each bar is given by the count for the bend. And I can see from my bends that the biggest count was 10, so I'll put 10 up here, and then I'll just divide everything as evenly as I can. 6, 7, 8, 9. So you will have to add your own scale to the vertical axis because it just depends on what the counts are and how high you have to go. So now I'm ready to draw my histogram. The first bar corresponds to the first count. So there were 3 things in the first bend. So my first bar should have a height of 3. My second bar was the big one. That went all the way up to 10. So my second bar has a height of 10. Notice that the width, my bars span horizontally the full range of the values that they're reflecting. There's no gaps between the bars here. The third bar has a height of 7. Fourth bar had a height of 9. The next bar had a height of 2. The next bar was the one that was empty. There's nothing in it, so you could draw a little horizontal line right at 0 if you like, but just skipping over that one essentially. And then we have 2 bars in a row whose height is 1. So that's what my histogram looks like. Just to make clear what I've drawn, to make sure my scale is clear, I should also over here write the word count or the word frequency or something. Anytime we write a graph with a vertical and a horizontal axis, we want to make sure that we have labeled the values and the meaning of those axes. That's how we did it in class, and your job for your assignment due Tuesday is to do that again for the set of data that was on your worksheet.